Hello, my name is Marco Steinbrugger. I'm gonna show you today how we're gonna do the timekeeping at this 24-hour run at the BSV Klagenfurt on the 25th of June 2022. So we do have two computer sets for redundancy. In this case, we're using a standard Windows 10 computer, and the software we are running to do the timekeeping is RCM Ultimate. It's the major brand for motor car racing companies and motor car racing clubs in Europe, and I think also worldwide today, which are using this sort of software. What you can do with the software is you can set up a race environment. In our case, it's a 24-hour run. You basically you set up a new race. Put in all the details needed. In the end, it's 4 teams containing of different drivers. You can set that up. I will show you that in a minute. And you can also use specific transponder numbers bound to these teams, so that the timekeeping will make sure that if the team 1 crosses the time counting line outside, that the correct car is counted. So in our case, I will show you how we set up this race for the 24-hour. Basically, you have in the main data, you set up the teams and the persons who are driving. So in our case, we have team 1, 2, 3, 4, 5, 6, 7, 8, and so on. As tomorrow, we're going to start with 2 or I think 3 teams. So in these 3 teams, you basically can go to the transponder information and set 1 to 4 transponders to this team. So in the case that a transponder has an error, you can switch always to a redundant second transponder. So first things first, the teams are here configured so that the automatic time system can work and identify the correct car passing the time counting line. The second thing we have to do here is we have to start a sort of race environment, which is basically made in the classes and the reglement that you're setting up there. So in the class, you can basically create a complete new class, which is in our case a 24-hour race, where we put in all the data needed to fulfill all the things we have to fulfill within this race environment. This is set. You can also put in the reglement. The reglement in our case is that we have, as you can see here, multiple reglements are set up in our system, but for this 24-hour race, we have a specific one. The specific one tells us that there is no training, there is no qualification, and there is only one final run, and the final run exactly can be shown here. There is a maximum of 5 teams that may start in this 24-hour race, and the duration is 23 hours, 59 seconds, and 59 minutes and 59 seconds. So this is the maximum that we can set here in our timing system. It's fully automated, and we have basically 3 number sets behind the counter. So it's basically you can drive one round, let's say 17 seconds for 1 round, and then 0.738. So it goes really to a very specific time limit. Once that reglement is set, we basically save it, and then we set up a new race environment. I already set up a testing environment so that I can explain to you how this will work. We close everything and we start from completely new beginning. So we start the program. We have here a special decoder from A and B. It's mylaps sports timing. So this is basically here. This is combined with the computer and with a specific wire crossing the track, so that whenever a car passes this specific part of the track, the time will be taken of the car. So we have lap counts and to a specific time. In this case, I will start now the timing system. I will load the test environment we basically clone for the tomorrow's 24-hour. And here I can then start the final race, and within the next 30 seconds of the countdown, or whenever I want to start it, in our case it's exactly 12 o'clock noon tomorrow, this race will start. So for this testing purpose, I will now pause this timer, and you can see here there is 4 teams set into the race. Exactly, I think it will be 3 teams tomorrow. You can see that the racing duration is 23 hours, 59 minutes and 59 seconds. And once you start the race, you will hear a special a sound outside through the sound system, which is installed on the whole racing track, so that the racers up there know exactly when they may start and when the 24 hours duration race will start. Once this race starts, which I will show you now for the testing purpose, I will hit the start button now. You can hear a sound, and then the race basically starts. So if you want to come a little bit closer, you can see that you have here the race duration. You can see here the time which has already taken place of the race. You can see the rest of the remaining time. And you can see here, this is basically we will make a standardized automated starting system, so that we have a special time plan, which will be tomorrow 12 point sharp at noon when we will start. And in this case, you can see that the timing is for this test purpose a little bit off time. Again, here at the bottom, I hope you can see that too in the video. You can see that there is a special time which is 5 seconds. So once a car passes the specific line, you have a 5-second time amount where the car may not pass the line again. So this would be if a car crashes exactly at the line, you may see more rounds that the system would take, and in case this doesn't happen, we made sure that there is a special 5-second delay time for the driver to may pass the line the next time. But this is basically the layout of this racing timing system. And you can see here, once a car passes the line, you will see here a red flash. So maybe we can make tomorrow a video to show you that too, how the timing system is working. You can see here the number of the car, you can see the team name, you can see how many rounds are already have been taken during the racing time, and you also see a forecast of the medium time of the racers, so that we already know if they keep the pace as they are right now, then you can predict what's going to be the final time after the 24 hours. And maybe we can switch over to our redundant second system, where you can show basically a live system also, where this 24-hour race is already pre-configured here too. You can see on this computer we have a second set of the hardware, so it's completely redundant. We have 2 completely separated timing systems. We have 2 different wiring systems which are completely on their own, so there is no parts which are touching each other or whatsoever. In this case, you might need to come a little bit closer to see also the numbers, because there I can show you now. This race is actually taking place for, again, the 23 hours, 59 minutes, 59 seconds. This demo race we started 6 hours and 57 minutes ago, and you can see that there is another 17 hours and 2 minutes and 45 seconds left of that race. So the combination of these times will sum up with a 24 hours and 59 minutes and 59 seconds. In this case, you can see that there has been multiple drivers crossing the line, and you can also see the driver with the transponder number 649777 and so on has already crossed the line 253 times during the last 7 hours. And the predicted racing time would be 3,455 laps in 24 hours, and this would be then 9 seconds. So basically you can see here the best time of the laps so far of these drivers on this test environment, and yeah, this is basically it. To explain how the systems works, both times of these computers, which are Windows 10 computers, the latest and greatest, we did all the updates and all the security updates. We also made a time synchronization with the Windows time server on both systems. So they are in the same, actually they are in different Wi-Fi environments, also to make sure that they are completely redundant. And the both should be on the, well, same tenths of a second or hundredths of a seconds of a time stamp using these time synchronization mechanisms. So thank you for well, going through the instruction of how our timing system works, and maybe we can walk outside for the last bit so you can see where these special wires are set. So in this case, this is the timing housing we have here. Special wires coming all the way from the computer over there to the time lapse. So you can see we built an extra redundant over the earth system where the wires go all the way there and all the way back. And we have the same system here. This is our main system. It's directly installed into the house, goes underground, goes all the way back here to somewhere this location. So it's about that deep, digged into the earth. Crosses the whole track over to here, line comes here back and back into the housing, so that the timing system here is the permanent one from our racetrack. This is the redundant second timing systems, and this is basically the hardware and the software explained in a nutshell. Thank you.